Welcome back. I'm glad you're still sticking it out in the middle of this identity journey with trigonometry identities. Uh, on this recording, we're going to look at half-angle identities. But before we can get there, we're going to have to develop something called the power-reducing formulas. We're going to use those to develop half-angle identities. So we're going to develop them, and then we'll do some problems where we use them. So first, we gotta look at the power-reducing formulas. Okay, if we start with the double angle identity that for cosine, one of those that we learned last time, if we start with the one that says that cosine of 2 theta is 1 minus 2 sine squared theta, we can do a little manipulating and solve for sine theta. So what we can do is subtract 1 from both sides. Then divide by negative 2 on both sides. Then clean that up just a tad. Sine squared theta equals, instead of having the negative on the bottom, I'll move it to the top, which will have the effect of changing negative 1 to 1, cosine theta to minus cosine 2 theta, and then over positive 2. And that's something called the power-reducing formula. And you can use that to help simplify problems where you have sine, like sine to the 4th of theta, or some higher power. And you can use it to rewrite things. Now there's a couple other ones that we can do too. Just like we have one for sine squared theta, we can do one for cosine squared theta. We could start with the fact that cosine 2 theta equals 2 cosine squared theta minus 1. We could follow the same procedure and solve for cosine theta. So subtract 1, or add 1 to both sides, excuse me, not subtract 1, add 1 to both sides. So we have cosine 2 theta plus 1 equals 2 cosine squared theta. And then divide by 2 on both sides, we end up with the cosine squared theta equals cosine 2 theta plus 1 all over 2. And that's another one of the power reducing formulas. Like if you wanted to, if something was in a higher power of cosine theta, then you could simplify it down to have only cosine to the first power. And then tangent, like if we were trying to do tangent squared theta, remember tangent is sine over cosine, so tangent squared is going to be sine squared over cosine squared. But we now know that sine squared can be written as 1 minus cosine 2 theta over 2, and that cosine squared can be written as cosine 2 theta plus 1 over 2. If we go ahead and simplify that a little bit, tangent squared theta equals 1 minus cosine 2 theta over 1 plus cosine 2 theta. So now we have all these formulas for sine squared, cosine squared, and tangent squared. And it actually gets everything down into plain old cosines. Cosines of 2 thetas. And these. But they call these the power reducing formulas. But we're going to use these power reducing formulas to develop half angle identities. Alright, let's first start with sine squared theta. Let's use that, from over here. And let's let theta equal alpha over 2. So then you got sine squared of alpha over 2 equals 1 minus cosine alpha all over 2. Because 2 times alpha over 2 will just leave you with alpha right there. Alright, so sine of alpha over 2 equals plus or minus the square root of 1 minus cosine alpha all over 2. And there is your first half angle identity. Now as far as the plus minus goes, decide which one based on the quadrant where alpha over 2 lies. Okay. Now we can do a similar process, starting with cosine squared theta equaling 1 plus cosine 2 theta over 2. So then we can say cosine squared of alpha over 2 equals 1 plus cosine alpha all over 2. So then do the square roots. So cosine of alpha over 2 equals plus or minus square root of 1 plus cosine alpha all over 2. So there's your half angle identity for the cosine. And then tangent squared theta equals basically sine squared over cosine squared, which we did earlier. We had 1 minus cosine 2 theta over 1 plus cosine 2 theta. So replace that theta with alpha over 2. So you have tangent squared of alpha over 2 equals 1 minus cosine alpha over 1 plus cosine alpha. So then do the square roots of both sides. Tangent of alpha over 2 equals plus or minus square root of 1 minus cosine alpha over 1 plus cosine alpha. And there you go. So in all of these, decide on which sign based on your quadrant where the alpha over 2 is lying. Okay, now before we do some work with using these identities, I wanted to take the tangent one and show you the development of 2 other versions of the formula. There's 2 other versions of the half angle identity for tangent where you don't end up having to worry about choosing the correct sign. It's pretty nice the way it works out. Okay, so let's develop those 2 just so you have them to use, and then after that we'll do some problems. Alright, let's start with tangent of alpha over 2. Okay, now let's rewrite to be sine of alpha over 2 over cosine of alpha over 2. Then let's multiply top and bottom by sine of alpha over 2. Let's rewrite this a little bit. Up top we could write that as 2 times 1 minus cosine squared of alpha over 2. And then on the bottom We can rewrite that as 2 sine alpha over 2 cosine alpha over 2. Okay, so do you see what happened there? Sine squared is the same thing as 1 minus cosine squared. So that's what got put in right here. This sine, this cosine is still here, but we multiply top and bottom by 2, which is perfectly legal to do with a fraction. Up top we got 2 minus 2 cosine squared alpha over 2. On the bottom we have 2 sine alpha over 2 cosine alpha over 2. Up top, we could take this 2 and instead write 1 plus 1 for 2, and then still have the minus 2 cosine squared alpha over 2 in here. And then on the bottom still have 2 sine alpha over 2 cosine alpha over 2. So I just took this 2 and separated it into 1 plus 1. But then you got 1 minus 2 cosine squared alpha over 2 minus 1. On the bottom you still have 2 sine alpha over 2 cosine alpha over 2. So you have at the top 1 minus 2 cosine of alpha. Oh, sorry, not minus 2. Let me erase that. No 2 right here. I was looking at the wrong thing. 1 minus cosine of alpha over 2 times 2, which would be just cosine of alpha. And on the bottom, sine of 2 times alpha over 2, or sine of alpha. So that's for tangent of alpha over 2. And the beauty of that formula is you don't have a square root, you don't have a plus minus to worry about. You just don't have any signs to worry about. You just put it in your cosine alpha and your sine alpha, and you can figure out tangent of the half angle. And you can do something similar you can get that tangent of alpha over 2 equals sine of alpha over 1 plus cosine alpha. That formula also works so that you don't have to worry about figuring out whether it should be positive or negative. So that's kind of cool. Okay, now let's see how we can use these identities. What can we do with this? All right, let's say you have to find something like the sine of 22.5 degrees. You're like, oh, Miss Schofield, I can't do that. It's not on my circle, and you're not letting me use a calculator. What do I do? Well, that's where half angle identities come to the rescue. 22.5 is half of 45. So you really have a half angle deal going on here. Let's see, 22.5 is found in quadrant 1. So let's see here. If we're doing the sine of 45 over 2 degrees, that's going to equal, since it's in quadrant 1, we're going to equal positive square root of 1 minus cosine of 45 degrees over 2. So we have the positive square root of 1 minus square root of 2 over 2, all over 2. So positive square root of 2 minus square root of 2 over 2, all over 2. So positive square root of 2 minus square root of 2, all over 4. So positive square root of 2 minus square root of 2, and that square root is over 2. And now you found the exact value, and you didn't have to have 22.5 on any kind of chart. As long as you knew the cosine of 45, you're able to use your half angle identity for 45 over 2 and figure out the exact value of sine of 22.5 degrees. All right, what if we have something like tangent of 75 degrees? Well, 75 is half of 150. So we can turn this into a half angle problem. We could say, well, the sine of, this is going to be the sine of 150 over 1 plus the cosine of 150. And 150 is on our circle. Woohoo! So we have 1/2 over 1 plus a negative square root of 3 over 2. So we have 1/2 over 2 minus the square root of 3 all over 2. So you have 1 over 2 minus the square root of 3. And if you rationalize denominator, like you guys learned to do in college algebra, you get 2 plus the square root of 3 over 4 minus 3, which is really just 1. So you get 2 plus the square root of 3. All right, let's do one more example. This one's a little more involved. It's going to be a little more fun. Let's see here. Let's say that you're told that the cosine of s is negative 3/7. Let's say you're also told that pi is less than s, which is less than 3 pi over 2. Okay, so s is located in quadrant 3. You're going to have to find the sine of s over 2, the cosine of s over 2, and the tan of s over 2. Alright, s over 2 then, if you look at s, it goes from 180 to 270. Well, half of 180 is 90, and half of 270 is 135. So s over 2 is going to be in here. It's in quadrant 3. So we got sines are positive, cosine, tangent, negative. So good to know. Alright, so dealing with s, we are told that the cosine is negative 3/7. Then let's see, 49 minus 9 is 40, square root of that. You got 4 times 10, so 2 square roots of 10, but it is negative, because we're negative y-axis there. So with that, the sine of s is negative 2 square roots of 10 over 7. We know the cosine of s is negative 3/7, because we were given that. And then the tan of s is 2 square roots of 10 over 3. Because negative over negative will make a positive. Okay, so let's use our identities now to help us out here. To find the sine of s over 2, we can use, let's see, so s over 2 is in quadrant 2, and that's where sines are positive, so we can use the positive square root of 1 minus the cosine of s, which is negative 3/7, all over 2. So we have the square root, let's see, 7/7, that'll be 10/7 on top, and then 2 on the bottom. So the square root of 10/14, same thing as the square root of 5/7. So it's going to be square root of 35 over 7 when you simplify that. So there's your sine of s over 2. And then for the cosine of s over 2, in quadrant 2, cosines are negative, so we have negative square root of 1 plus cosine of s, so that was negative 3/7 all over 2. So negative square root of 4/7 over 2, so negative square root of 4/14, or negative square root of 2/7. So it's going to be negative square root of 14 over 7. And finally, the tangent of s over 2, we could just put sine over cosine. We could put square root of 35/7 over negative square root of 14/7. It's going to give us negative square root of 35 over square root of 14. If I go ahead and put that under 1 hat, I can do a little reducing and see if that makes it a little easier. Not really, kind of. So negative square root of 10 all over 2. And there we go. So we were just able to look at just a few pieces of data, very little data. The cosine, and then the quadrant for s. And from those 2 pieces of data, we were able to figure out the sine of the half angle, the cosine of the half angle, and the tan of the half angle. And there you go. So that's the half angle identities. Next up, we've got the product to sum and sum to product identities. So those will be coming up next, and that will wrap up all the trig identities that you guys are going to be responsible for. So tune in again for some more identities. Thank you for joining us.